So what is EERAdata for the people that don't know exactly what we are doing? EERAdata is a Horizon 2020 project in which we assist municipalities from the beginning, like from the collection of their data, building stock data and social data, ecological and economical data. And we help to gather this data, to assess this data and prepare this data. Why do we do this? We're developing also a tool which is using this data to assessing the sustainable renovation activities of portfolio managers, cities planners, and related stakeholders, which means that we are providing assessments for a specific building. For example, you select a school that you want to renovate, and we provide the full assessment for it related to indoor climate, to the socioeconomic benefits, the ecological quality of the buildings, kind of the potential which lies in it when we renovate this building. And with a quite limited amount of data that you provide, we can produce quite profound results. This should help to find arguments, a chain of arguments on a policy level, on a budget level, to force or to foster on renovation strategies, that we focus more on energy efficiency than new constructions, that we see all the wider benefits that are getting out from it. Yes, this is what we basically do. Then the consortium, and a lot of people from this consortium are here today, consists of 2 universities. That's the Technical University of Munich. This is where I am based. Then we have the Danish Technical University in Copenhagen. They are focusing on the indoor climate. We have 3 other scientific partners. It's ITTI, which are doing the programming, coding, they're constructing the tool, and they are of a big help when it comes to the data intake and the overall architecture. We have Trilateral Research, who are responsible for our communications and the data science behind all this. So most municipalities know them already, and you will get to know them much better in the next months when we're getting much deeper into data collection. We have XENA from Slovenia, who are an energy agency helping municipalities to produce renewables and energy efficiency concepts. And then we have 3 implementing partners, and I know that most of you are part of these implementing partners, which is very nice that you're here, because we want to know what the practical use of our tool would be. And we have the city of Velenje, which is in Slovenia, as a practical implementing partner. We have the city of Copenhagen, and we have the region of Andalusia, represented by the Energy Agency of Andalusia. So thank you for all the partners, and the Arquitectos de Málaga, sorry, that are heading the implementing of the project the next months, and they will become a special role in the next months, coordinating all this testing and implementing phase. Yeah, that's the consortium, and I think in the discussion we'll get to know us much better, because we're all present and we will be distributed into different groups. Why do we have this kind of consortium? We wanted to reflect 3 different regions or climate regions of Europe, Scandinavian part with England, Denmark, and also Sweden, Norway. Then we have the Mediterranean hot climate with Andalusia. And Andalusia is special because it has a lot of climate zones, a lot of different parts which we can intake in the project. And then we have the kind of continental mountain climate from Velenje and Slovenia. So kind of reflecting a little bit the intercontinental part. This is what I wanted to tell you about the project in general, but now we are coming to what we're actually doing, and what is the core work of what we're doing. And I think this is the most interesting, and this is also what we want to discuss today. One part is the data, of course. We are having basically 2 databases. One part is the real data. This is coming from the municipalities. This is coming from the regions. This is coming from specific buildings, where we, for example, asked about the geometry, the heating system, ventilation system, the building materials of specific buildings. This data will get fed into our calculation modules, and then we combine it with default data, which we generate as a team, from science, from models, from experiments, from various sources. We define data sets that help us to calculate So for example, we get the geometry of a building, and then we calculate the energy consumption out of it. It's not something that we can make up. So we are relying on existing models, on weather data sets, on terrain, on location sets, and we're combining these two streams together. You can see it here in the next slide, where it kind of comes together. From the EERAdata side, we have the scientific data, we have the model simulation, statistical data, experimental data, knowledge data, and then from the left side, it's kind of the real data coming from the end user, coming from the municipalities, which is building stock data, socioeconomic data. So what are the wages of the people working in the municipality? How many construction companies are there? How many jobs in the construction sector are there? Is there any special issues with mold or quality of buildings in a municipality? Or is there health issues due to environmental problems? Is there any scarcity of water, for example, in the summer months? All these things that are real and coming from municipalities are also mixed together in the tool. And when we have the data collected, we go to the next step, which is kind of the calculation modules. We have it separated into 5 different modules, and these modules create some outputs. These outputs we want to discuss today because we will have a lot of results which are interconnected, but we want to know from your side how we would like to present the results. How would you like to see it, and how do you like to work with all this information that we are generating? Maybe there's some things that are completely obsolete for you, okay, in your case. Maybe there's other things that are not represented now and are very important for you. So this is, this is what we want to find out today. Let's start with the different modules, and then we can kind of come to the discussion. So I mentioned already, we have the data preparation module. This at the moment looks like we have a very extensive Excel database, which can be filled by you, which will be filled by the municipalities and regions with a strong guidance from our side. So it's kind of a template that's getting filled, and then in the next level, it's getting integrated into the tool. I don't want to go very detailed in this because this will be part of another workshop where we really make some training about the data part, but just to have it in mind. Then the first, and I think it's the core module, is the energy demand calculations. For the most buildings, we already have the real consumption, so this part is not really, it's not used that much. But for buildings where we don't have the energy demand, where we don't have the energy consumption, where we don't have the heating demand or the different energy sources, CO2 emissions, this module is kind of the core module because it produces what we're dealing with. And it can also tell us which renovation measures have which effect on the energy demand, for example. This is based on a static module or modeling where we use heating and cooling degree days. We use the U values of different elements of the building. We use weather data, and then the typical energy sources. And of course, we integrate the effects of renovation measures. Outputs here are the energy demand, the primary energy consumption, the heating demand, cooling demand, and also in a later level, the CO2 emissions, the particulate matter emissions, energy consumption reduction through applied renovation measures. And these outputs are feeding into the life cycle assessment, indoor climate, and supply side assessment modules, which I will explain in the next slides. The next level is the resource life cycle, which means we're looking into the materials that are used for the building, and especially what materials are safe because we're renovating a building and not constructing a new building. And we're also looking into the greenhouse gas emissions over the lifetime of a building, and in particular, the technical devices that are, or the technical services, for example, heating systems that are included. So we're looking into all these from a life cycle perspective, saying, okay, where's the resources coming from? How much energy did the materials consume when they were constructed or built, and then when they were implemented? How much energy is consumed through the operating phase, and how much when we deconstruct everything? So we're looking all the different steps, and this is based on mostly based on databases and a calculation model, a static one. And there we were relying a lot on the building information, technical building information, building age, renovation circles, how long is kind of a technology lasting in a building before it breaks or before it has to be replaced. The outputs here are the embedded energy of building components, especially also for the building services like heating systems, cooling systems. Then the greenhouse gas emissions over the lifetime of a building, the environmental impact of building renovation, maintenance, operation, and demolition, and CO2 emissions or CO2 equivalent per year. And then, of course, the resource consumption, including water in some parts. Yeah, and this is also feeding into the socioeconomic assessment. And here also, here we have also the first module which has direct link to the results, because here we create the first results that are interesting for you. The next module is the indoor climate module, which is a semi-dynamic simulation, I would call it like that, where we assess the situation indoors without having measures or kind of any measurement installed in a building. It's based on indoor temperature and the CO2 concentration curves, which are indoors. We are kind of calculating the indoor temperature and the situation concentration, but because we know the window size and opening of a building, the terrain and weather data, the building curvature and size, and of course the building services. And based on previous experiments and observations and scientific modeling, we can predict more or less how the indoor temperature and CO2 concentration develops over time, and also how it affects the productivity, the well-being of people inside. And this will result in the quantification of productivity effects, well-being effects, health effects on a later level. It's, for example, sick days or, yeah. Then we have the monetization of indoor climate effects on health, productivity, learning, and well-being, which means we will try to put money on or costs on the productivity losses that are induced by a bad climate indoors. And at the same time, we can also say how many benefits we create when we create a good indoor climate. Then we look into the indoor air quality. We try to quantify that. And also the occupant behavior data, like how do people open windows and how do they behave indoors. So this is also an output we are creating. And I'm very curious to know your opinion about that, how you would use this data and how you want to have it presented. Then we have the socioeconomic part, which is kind of combining all the output that we generated so far and putting it one step later. So this is kind of the next chain effects. If we have, for example, the investment in renovation measures, here we can create how much this investment, so this money that is pumped into the market, how this money creates jobs, for example, or it impacts the GDP, or it impacts the wages. In the same time, for example, we use the outputs of the indoor climate module, and then we can see, okay, how does it affect the health expenses? How does it affect the general occupant health? And then we put some numbers to it. The numbers are coming from other modules, other models which were created outside of this project. And for example, here we can assess the impact on the occupant health. We can see, okay, outdoor air pollution, how is it influencing the mobility of older people? I think during COVID-19, also the discussion about the outdoor air quality in cities and how it affects our health was discussed very, very much. And I think we are affecting this with the buildings as much as we do with cars or anything else. Then we check out the impact on environmental resources. So how much water do we consume? How much CO2 we do emit? And it's very related to the previous modules, but it just goes one chain after. For example, the impact on poverty. How much tax returns can the municipality count with in the different countries and regions when they invest in a building? How much does it comply to the CO2 emission targets? into the political goals, and also kind of the things like property assets, and these, yeah, parameters. It's based on statistical data. It's based on a probability-based approach, which means that it's very transparent. We can show you in every step what data is used, and where the estimates are and how precise the estimates are. That's the idea. So please keep this in mind when we talk about it later, that this will be kind of a very transparent way of presenting these results. It's not like we say, okay, in average, Europe creates 13 jobs per every million invested in a building, but we try to say, okay, in Velenje, there's maybe 2 jobs created or 3 jobs created because we know that there's these and these companies or this amount of people involved in the sector. And you can see this in a transparent chain of, it's kind of a blockchain with information. Yes. And this feeds into the supply side assessment and the reporting again. Last module is the supply side assessment, which is kind of the counterpart of the energy efficiency. Here we want to see, first we assessed all the benefits that are generated because we are putting energy efficiency in a building. We are renovating it, we're putting more efficient technology in it. And here we want to see, okay, but what is happening if we put the same money into supply side measures like renewable energies or on-site renewable energies like solar thermal plants, district heating. What happens if we do it there? Isn't it better to go for the supply side? We are here to prove that it's not better. We are here to prove that energy efficiency should be implemented first, and second, the supply side should be implemented. So this is also a very important module, which generates an output which is kind of outweighing the different benefits. Yeah, and this is also the outputs of this module. The benefits of renewable energy, sustainable supply side solutions, and centralized and decentralized solutions. Just to give you a short overview of the interface, closing down the modules that we have. So it will be kind of a decentralized tool that will be installed in your computers locally, but it has kind of a browser feeling when you use the interface. It will have, you can select buildings, you can select renovation measures, and then our tool will make the calculations. This is something that we will highlight this in detail in a later stage, but just to let you know how it looks like from the first perspective and how you would use it. So you kind of you go into the tool, you have this surface like you see it here. It will change a little. It will be more user-friendly later on, but for now it looks like this. Then you select the projects that you want to address, and then you work with, and then you select renovation measures for this building, or you can select pre-selected packages, kind of strategies that are inside the tool, and then we create these calculations, and you get the outputs, the assessment that I just mentioned in the different modules. This is how it's planned to be. And yeah, it's good for us to know, yeah, what of these do you want to select them one by one, the outputs, or do you want to have a finished report without so much to change about? This is something we want to discuss. Well, some ideas we already have about the reporting is that we thought it would be nice to have different scenarios. So you can select 3 different scenarios, maybe saying we're going for a worst case scenario to a good scenario. This is reflecting the energy prices, for example, or yeah, the general situation in Europe, environmental costs, CO2 costs, all these things. Then another idea is that we have compiled results, so you don't get everything single by single, but we have outputs that are already condensed to maybe a chart or some bar charts and combining results. And this is why you're here as well, is we want to target the results to different user groups and saying, okay, not every way of presenting is good for every user group. For example, the very technical user, the consultant, wants to have very detailed data and maybe wants to have the raw data to process it further. And a person who is responsible for budget just needs to have the rough overview of the benefits that for every euro invested in the project. And there's a lot of people in between with different ideas and different solutions. Yeah, and then we have the visualization, which we thought would be good to have it in GIS, in a geoinformatics system, so you can select the buildings on a map and you get also the information on the map. Depends a little bit on how you have your buildings organized, but I think the most municipalities in region have a cadastre system. Not all of them have 3D models like we see it here, but this can be an idea for the future. And then we have an expert mode, like I mentioned, for the data processing. What are our target users? Our target users are at the administration level, like political policy level, people that decide in municipalities what is implemented, what not, in which direction we should head. Maybe they give the last go, like the city councils. In a lot of small municipalities in Germany, for example, the city councils have the last word. They decide what is implemented and what not. Then we have the strategical level, users in budget and planning, meaning, okay, there is a head of department that plans a renovation strategy, and they have the overview of what is done, what not, and they assess the budget, and they assign the budget also to different projects or to different measures. And then we have the detailed level, the technical consultants, agencies, the ones that are really going into detail, that are assessing the buildings, that are preparing the different renovation measures, that are making all the reports and detailed technical plannings for the building renovation. For your examples, how these visualizations could look like, for example, here we have it for different countries. It could also be for different buildings. And on the left side, we have it a very simple standard results, which are, for example, here the mortality, which is reduced by energy efficiency measures. And then on the middle part, we have a very complex depiction with numbers and different more layers for an expert. And then on the right side, we have a visual graphic depiction of it. Yeah. Now we are ready to start a discussion.